Yes, welcome back. So today we are going to discuss Module 5, RTOS and IDE for Embedded System Design. So in the previous session, you people understood embedded firmware design and development. So the different approaches for developing the embedded firmware software. So now today we are going to discuss more with respect to the operating system. So that is real-time operating system. Now for today's session, we'll be understanding the operating system basics. So and in subsequent classes, we'll be focusing more on the RTOS and its the IDE, integrated development environment for the embedded system designs. In the previous class, we understood two approaches for developing the embedded firmware system. One is super loop based approach, another one is the operating system based approach. And in the super loop based approach, the other name is the conventional procedural oriented programming. So, or you can also call it a super loop based execution. In super loop, the super loop based approach is used for developing the embedded firmware, where the time is not an important factor, because the task execution is non-real time. Now such systems are developed using the super loop based approach, and there are a few applications which demand the time critical responses. They are called as and those systems they are developed using the operating system approach. And few examples for the application which demand the time critical responses and which are developed using the operating system based approaches are the flight control system, airbag control, which is used in the cars, and anti-lock brake system, which is used in again the vehicles, and nuclear monitoring devices. So these are all few applications which demand the time critical response, and these systems they are developed using the operating system based approach. Now in all these systems you require the operating system, whereas the application which doesn't require the execution in critical time response or the task execution which is non-real time they can be developed by using the super loop based approach, or the sequential programming, in other words you can call it as. Now in embedded system, the time critical response for the tasks or the events may be addressed by, say for example you are developing an embedded system which requires a time critical response. Now how do you address the tasks or the event in such systems? One approach is by assigning the priorities to task and execute the highest priority task. So you should have a mechanism of assigning the priorities to the task, and always the task with the highest priority should be given the chance to execute. And the second thing that is required in the embedded system, which has a very high time critical, which require very high time critical response, is dynamically changing the priorities of the tasks. So dynamically changing the priorities of the task if required on the need basis. So it's not like assigning the priorities to the task at one time and keeping quiet, but the priorities of the task should be changed dynamically during the execution time, so based on the needs. That is another important thing that is required. And the third is the introduction of operating system based firmware execution in embedded device can address these needs to a greater extent. That is, as I already told, in this type of system which requires a time critical response, in addition to these two, if you have the operating system based firmware execution, so then all this time critical requirement can be easily met. Now time to understand few basics of the operating system. Now OS, as all of you know, it acts as an intermediary between the computer user and the computer hardware. So because as a user you are not allowed to directly use the hardware resources in order to perform the required computation. Now we say the operating system stands as a bridge between the user applications, or you can say the users and the computer hardware resources. That means the operating system facilitates the use of hardware resources to the user applications, or in general the users. So or in other words, you can also define operating system as the resource allocator. It is also responsible for fairly allocating the limited resources which exist in the within the system to the processes that are running on it. Now this is what is the operating system, say which acts as an intermediary between the user applications or users and the computer hardware resources, or facilitates the use of all these hardware resources by the applications that are running. Next we have what are the primary functions of an operating system, or what are the primary goals of the operating system. So the first major goal of the operating system is to provide the convenience to the user, that is making the user use the system easily. That is what is convenience. Now if convenience is the major goal of the operating system, so then the performance will go down. So as the convenience increases, the performance will obviously reduce, because you will be writing more overhead instructions or the overhead piece of programs just to provide the easy access and easy interaction for the user. So one advantage is it makes the user easily use the system, but at the same time the performance will decrease. So that is what the comparison is. Say for example, I have a very good graphical user interface based system and another system which provides the same services but command line. So this command based system is much faster. It will be much faster than compared to the UI based system. Ultimately they are providing the same service, but this is command based and that is graphical user interface based. And when I say graphical, this is the overhead, and there is more burden on the processor to perform the execution of this UI component as well. Hence we say more the convenience required, so you have to sacrifice the performance. So one major goal of the operating system is to provide convenience to the user, and another important major goal is organize and manage the system resources efficiently and correctly. That means it manages all the resources, hardware resources, limited resources, and also knows how to allocate them fairly to the number of different processes running on the system. So those were the two major functions or the goals of the operating system. Now this diagram depicts the various components or the basic components of the operating system. You have the user applications here on top, and then you have the underlying hardware. So in between the underlying hardware and the user applications, you will find many layers. These are all the services which are offered by the operating system. One is IO system management, file system management, time management, process management, and memory management. And each of these services that are offered by the kernel, we are going to discuss in detail at a later point of time. So this is input-output system management, which is responsible for getting the input from the external devices and also sending the output to the external devices. And file management system is responsible for storing all the files, related information into files, and related files into the directories, like this. This is basically responsible for storing all the files. And time management, because when I say the applications are running, time management is also very much important, because you cannot keep the same process running forever all the time. So a fair chance should be given to all the processes also. Now we require the time management, and next we have the process management, which is again a very important topic, which we'll be discussing later. So process is a program which is loaded into the main memory and which is under execution. A process is basically an active entity because it is loaded into the main memory and it is under execution, whereas a program is just a passive entity like any other ordinary file stored on the disk. Now how do we manage the process, how a process is created, how the process will execute, how it gets scheduled for execution, how the process will synchronize with the other process. All these things we understand in this topic when we go there in the later classes. And then memory management, again this is another important service provided by the kernel, which manages the memory, and it's responsible for allocating and deallocating the memory. Now when the memory is required for a process, it allocates the memory, and memory is not required for the process. When the process is finishes its execution and gets terminated, so the memory management unit is again is responsible for deallocating the memory and making the memory available for the another running process, another process which is waiting to get executed. So this is the pictorial represent. These are all, we say, the basic kernel services. What is a kernel? Kernel is again the core part of the operating system is called as the kernel, where the most basic services offered by the operating system are residing. That we call it as the kernel space. Now, kernel is the next topic. Kernel, as I already told, is the core of the operating system, the main part of the operating system, or you can say the heart of the operating system. Now, I say for the system, operating system is something like the heart, and for the operating system, the kernel is something like a heart. So, why it's called as the core part of the operating system? Because inside this, you'll find the most basic services, and it is responsible for managing all the system resources and communication among the hardware and other system services. So and I can say that this sits between, it's a layer which sits between the system resources and the user applications. Now, kernel also contains something called as system libraries and the services. When a user program or a user application is running, so it will communicate with the system libraries and the services. It will make use of these things, and for an application program to make use of these things, it has to make a call to the API, or in other words, you can also call them as system calls, because system calls, as already told, they are something like an entry point to gain access into the kernel, or in other words, simple terms, they are something like doors in order to gain access into the kernel. And many examples are there. Later I'll tell you. System libraries and services, they are inside the kernel, and whenever the user process wants to call the system libraries and the services which are there inside the kernel, so the CPU itself will switch from the user mode execution to the kernel mode execution. Now, kernel mode execution is a protected mode execution where the CPU has access only to the kernel resources. When it is accessing the kernel resources, it is not possible for the CPU to access the resources which are in the outer side of the address space. So the general purpose operating system, the kernel contains different services like memory management, process management, time management, file management, and IO system management. These are the things which I already talked in the previous slide. Now, process management, this is again one of the important services that is offered by the kernel of the operating system. Now, what are the facilities or the functions that is performed by the process management? As I already told, process is the active entity, or in other words, simple terms, if you want to define a process, it is the unit of work. So what process management does is it's set up the memory space for the process, or in other words, it allocates the memory for the process, and then loading process code into the memory, allocate the system resources, scheduling and managing the execution of the process. It decides when the process should be scheduled for execution, or in other words, it decides when the process CPU should be given to the process for its execution, and managing the execution of the process, how long the process should be allowed to execute, and when the process is executing, does it require any other resources to complete its execution. Now, all these things is done in the process management task. And next is setting up and managing the process control block. And every process has something called as process control block. What is process control block? It's a data structure that every process maintains. Whenever the CPU switches from one process to the another process, all the intermediate results of the process which was currently executing in the CPU will be saved onto its PCB. And again, when the process resumes its execution, so the previous state will be reloaded to the CPU from the process control block. So process control block, this is very important, because every process will have its own process control block, and this will be used by the process in order to store its status information whenever the CPU switches from that process to another process. And this process control block helps in reloading the status of the same process when the CPU switch backs to it. Inter-process communication and synchronization also. Now this process management is also responsible for making one process communicate with the other. So the different mechanisms, different ways to make the one process communicate with the other, and when they are communicating, multiple processes are communicating, and if they are sharing some kind of shared resources, so like it could be a simple memory or any other resource, physical resource, then a proper synchronization has to be provided among them. Now and then again many algorithms will come based on the process synchronization, and so this is really very interesting topic. And next, finally, when you do all these things, the moment the process does its intended computation, so the operating system or the process management component within the operating system will go for terminating the process, or you can say the process deletion. Once the process is terminated and deleted, so all the resources which were used by this process during its lifetime for execution will be released back to the system such that they are available for the next process which is about to execute. Next is the primary memory management. You understood process management. Now primary, or you can also call primary memory, you can call it as, or you can also call it as a main memory. Now, and main memory or primary memory is a volatile memory. That means you cannot store the data permanently there. So the data gets stored there as long as there is a power supply to it. The moment the power supply is stopped, so all the data which is stored inside the RAM or the primary memory or your main memory will be erased. Now, and the best example for the primary memory is the RAM, where the processes are loaded and the variables are shared and the shared data are stored. And here, in order to manage this, the primary memory, we have something called as main memory management unit. Short form it is also called as MMU, and this is again the part of the kernel which is responsible for tracking which part of the memory area is currently used by whom, and it also knows which process has used how much amount of memory. And this MMU is again responsible for allocating and deallocating the memory space as there is a need, on the need basis. Whenever a process is ready to execute, so MMU will allocate a memory for that process inside the RAM, and whenever the process gets terminated or finishes its computation, MMU is responsible for deallocating the memory space which was allocated to it. So next is the file system management. So this is more related to your secondary storage device, hard disk. So a file is a collection of related information, and again a group of related files, you are going to combine them and you're going to store them under a directory, and in normal terms now we call it as the folders. Now when I say a file which is a collection of related information, a file could be a program, because program is also a collection of related instructions. So, or it may be an ordinary text file, image files, Word documents, audio, video files. These are all these things can be called as the files, and these files are stored on the disk. Now, how the file management is happening, and again there are many different types of file management systems. So it depends. File allocation table, FAT32, and then NTFS, network file system format. Many things are there. Now, what this file system management is, which is present inside the kernel, or which is also a part of the kernel, is responsible for. It's responsible for creation, deletion, and alteration of the files. Using this file system, and this file system management support creation of files, deletion of files, alteration of files, and creation, deletion, and alteration of directories as well, because directories will contain the related files and file contains the related information. Now, and this is also responsible for saving the files on the secondary memory. So the secondary memory could be your hard disk, or it can be any solid state device, and even it can be your CD-ROMs or the DVD-ROMs. And provide an automatic allocation of file space based on the amount of free running space available. So this again, file system management is completely responsible for automatically managing the space available within the secondary storage devices, and providing the flexible naming convention to the files. You are free to give your own names to the files such that you can remember the file names for a longer period of time. Next is IO system management or IO device management. So kernel is again responsible for routing the IO request coming from the different user applications to appropriate IO devices of the system. When I say IO devices, input output, so you can have multiple input output systems. So because the basic two input devices for the system is one is mouse, another one is a keyboard. So apart from this, you can have many other input devices also. Say for example, you are using a gaming device, and if there is a joystick is also an input device. And similarly, you could have multiple output devices as well. So the standard output device is the monitor, where you see the results given by the computer system. So like this, you can have the output devices at the printer or many other devices. Some devices, external device connected to the laptop, to where you are sending the output produced by the system is also an output device. Now, how the kernel again as a component or the part which is responsible for managing all the input output devices. Now, and every device has something called as device manager or the device driver, which is responsible for controlling the functioning of that particular IO system, input output system. And device manager is responsible for doing all these things, loading and unloading of the device drivers. So because every input output system will be having its own device drivers. Say keyboard and mouse, so the device drivers is built into the ROM itself, because it's called as basic input output system. For any computer system, this keyboard and mouse is the basic thing, and for that the device drivers is found inside the device drivers, exchanging information and the system specific control signals to and from the device. Next is the secondary storage management. Deals with managing the secondary storage memory devices connected to the system. So it may be an hard disk or the other external storage device like CD-ROMs or the DVD-ROMs. So in most of the secondary storage, in most of the system, the secondary storage is kept in the disk, the hard disk. Now examples are so the secondary storage management, the secondary storage management service is responsible for doing all these things: disk storage allocation, disk scheduling, and free space management again. So next is protection system. Operating systems are designed in such a way that they support the multiple users and multiple applications. So since it is supporting multiple users and multiple applications, there should be the different levels of access permission given, because it is supporting multiple users. So and see why the protection system should be there, because you have the process from many different applications or processes from many different users running on the system, and it should not be possible for one process to access the address space or the memory region of the another process. So hence the memory protection systems are required, and this system, which is there inside the kernel of the operating system, will ensure that the process, when it is executing, it is allowed to access only the system resources which is related to it, and it cannot access the resources of the other processes. Now, interrupt handler is also another thing that is provided by the kernel. If the immediate attention of the processor is required, then this interrupt handler will assist in that. So the interrupt is generated, that goes to the CPU, and you have the immediate attention. You're drawing the immediate attention of the processor, and you can make the processor to do some other work, the emergency work. Now, important services offered by the kernel of an operating system. So, kernel space and user space. There are two things. You can also call it as kernel mode execution or user mode execution, or you can also call it as kernel space and user space. Now, let me tell why it's called as kernel space. Kernel space is the memory region where the kernel part of the operating system is residing, and user space is another part of the memory where the user applications are residing. When the user application, as I already told, makes a call to an API or makes a call to the system call, what will happen is the call will be made to the functions or the services which are present inside the kernel space. That time the CPU will switch from the user address space to the kernel address space. That means the CPU will go for executing the service which is there inside the kernel space. When the CPU is executing inside the kernel space, it is in the protected mode. So that means it has access to the kernel resources. And when the CPU is executing inside the kernel resource, nobody can disturb it until it voluntarily